Hello everyone, Miss Katungo here. This is another physics related problem. But before we get into the problem, don't forget to like and subscribe to my YouTube channel. Let's get to it. By reference to vibrations of points on a wave and to its direction of energy transfer, distinguish between a transverse waves and longitudinal waves. Transverse waves is basically defined as vibrations that are in the direction perpendicular to the energy transfer, while as longitudinal waves we have disturbances or these vibrations that are parallel to the direction of the energy transfer. So therefore, in distinguishing between the transverse T, the transverse wave, and in distinguishing the longitudinal wave L, we can distinguish them in terms of their directions of the energy transfer. Okay, so let's get to the other part of the question. The variation of the distance x with the displacement y of a transverse wave is shown in figure 14.21. Okay, use the figure to determine the amplitude, the phase difference between point A and point B, and finally determine the amplitude of the wave with twice the intensity as that shown in the figure 14.21. Let's begin by determining the amplitude. Okay, so as we said, the amplitude is simply the maximum displacement of this particular wave from its rest position point. And so therefore, we will have the maximum point there to the bottom part as the amplitude, which is A. And so the amplitude A, if we measure from the bottom to the highest point of the wave, which is the crest, we will have the amplitude being 2.8 centimeter. Okay, so let's get to the other part of the question. The phase difference between the points A and point B. Phase difference is basically given by the change in theta, or the change in the phase, is equal to the change in x over the lambda, which is the wavelength, multiplied by 2 pi. Or in most cases, people would replace this with 360 degrees. Okay, so finding the change in x between point A and B, we'll have our change in x being equal to 0.3, as point A is 0.4 and point B is 0.1. Finding the difference between these two, we will find our change in x as 0.3. Okay, our lambda, which is the wavelength. The wavelength, as defined, is basically the distance between two crests. And hence, if we determine the distance from here to that point of the wave, this will give us our lambda. Hence, our lambda there will be equal to 0.8, or we can begin from this point of the wave to that point of the wave, and we'll obtain our lambda as 0.8. Finding our phase difference, it will be obtained as 0.3 over 0.8 times our 2 pi, hence having it as 2.36 rad. This can also be obtained in degrees. Okay, so let's get to the other part of the question, rather the last part of the question. Okay, determine the amplitude of the wave with twice the intensity as that shown below. So the relationship of intensity and the amplitude is practically given as the intensity is directly proportional to the amplitude, to the square of the amplitude. So meaning that if we increase the intensity, then the amplitude increases as well, because they are directly proportional. Okay, so since it's twice the intensity, and finding for intensity, we can say twice of the intensity is equal to the square of the amplitude. And if we are to determine the amplitude, by what factor is the amplitude going to increase? So we can square that, and we'll have the amplitude being increased by the square of 2. So meaning, if we increase the intensity, or if the wave has twice the intensity, meaning the amplitude will basically increase by the factor of the root of 2. Hence, finding the new amplitude, we'll have A being equal to the root 2, which is the factor, multiplied by the amplitude. Hence, we'll have the amplitude being 3.9598, and the amplitude will finally be 4 meters.